Okay, so video number 2 about estimating mu using a confidence interval. Now here's your formula. It's always your estimate, which is your statistic that mirrors what you're trying to estimate, plus or minus the margin of error, which is the number of standard deviations wide you want to go times the standard deviation of, in this case, x bar. Now the reason this isn't a z is because as sample size gets bigger, we get closer and closer to being approximately normal, and this t star takes care of that difference between the normal curve and what this curve would look, your x bars would look like for a given sample size. And this degrees of freedom idea goes along with that. We're going to use our calculator to get this value, as you'll see. So here is an example. All right. So let's estimate the true mean age of pennies in people's houses around Hannibal. All right, so here's Hannah's sample from her pennies of size 40. She had an average of 38.6 with a standard deviation of 36.8. Right, so say, okay, let's use these values to estimate the true average age of pennies. Let's see if I can get a little more light on the situation here. Alright, so the first thing I do is make sure your sample is good by checking the conditions. Right, Hannah says she went and picked her pennies at random. Even your entire stack of pennies in your penny jar most likely could be considered a random sample because you didn't just go out and get them all at once or target them. You just collected them as you got them from different stores or found them here in the couch or, in the seat of your car, something like that. Ooh, a giant stink bug on the light. Giant. Climb onto there. All right. Now I'm gonna. There he is, Mr. Stink Bug. He's gonna follow the lesson for one more second, and then his days are over. Okay, so we assume that Hannah's are random. Now we got to population, or sample size needs to overcome population skew. Now we know that the age of pennies is skewed to the right. Most pennies are pretty new, and as you get older and older, there's less and less pennies. But a sample size of 40 is almost always good enough to overcome skew. The rule of thumb is bigger than 30, you're okay. Less than 30, you have to check for skewness somehow. And then the 10% condition, 40 is definitely less than 10% of all pennies that are out there in circulation. So first step, check the conditions. And then once I check the conditions, I can make the confidence interval. Right, so let's do a 95% confidence interval. So formula, your guess, which is the sample average, plus or minus t star, sample standard deviation divided by square root of sample size. On the first set of notes, I said sample size, but I put the wrong number in there. All right, so go back and check that. It should have been a 30 instead of a 20 back on the notes. Thanks to Matt. We caught that. Okay, so now I have to do these calculations, and our calculator is really good at calculations. So bring out my calculator. Now it's an interval. and I'm looking for a t interval, not a z. Skip over the z and go to t. We're using a t star score. Just doesn't quite want to focus. Okay, and then enter, and then the information. We don't have data, we have the statistics. So go over to statistics, hit enter, put in your information, 38.6. Standard deviation of the sample, 36.8. Sample size is 40. Confidence level is 95. Calculate. 26.8, comma 50.4. Okay. So now state that in context. I'm 95% confident that the true mean age of pennies is between 38.6 and 50.4 years. Okay. And that's all you need to show. Use your formula, plug in the numbers, let your calculator do the calculation. Don't worry about putting the t star score in. It's around 1.96 if you want to go 95%. It's close. The bigger the sample size, the closer it gets. I'll show you that in the next video. I'll show you the table. All right, so now if I want to make a 90% CI, 90% confident. Now I'm less confident in my estimate, but as you get less confident, the reason for that is because your net isn't quite as big. So you have a more narrowed estimate. So stat test number 8, and all I gotta do is go down and change this to 90. You can put 90 in there too, it'll work. Okay. 28.79. Well, let's go 7. Let's go 8, 0, and 48.4. So 28.8 to 48.4. Okay. Narrower. Instead of 26 to 50, it's 28 to 48. But I'm less confident that I captured the true mean age of pennies. I'm 90% confident that the true mean penny age is between 28.8